Okay, so this is a continuation of 4.1. I guess this would be 4.1b. Um, the second derivative, you can actually use, instead of doing the first derivative test where, let's see if I can recap this maybe. First derivative test, you would find the derivative, find where f prime is 0 or undefined, then put those on a number line, do an f prime number line, and test values. So that's the first derivative test. The second derivative test is similar but different. So you're going to find the first derivative, find the critical values. Then you're going to find f double prime. These are these steps I've listed down here. Find f double prime, and then see if f double prime is positive or negative, and that will help you determine whether your critical value is a min or a max. So again, this is in the end of the last video. If it's a local minimum, it's concave down like a frown. Sorry, that is not right. If it is a local maximum, it is concave down like a frown. If it is a local minimum, it's concave up like a cup. And I know y'all can't see me, but I always hold my hand up like a cup, and that means it has to be a minimum. If it's down like a frown, then what's happening is happening on top of my hand, so it has to be a maximum. So if f double prime at your critical value is less than 0, then f of c is a local maximum. That would be concave down like a frown. If it's positive, then you're looking at a local minimum up like a cup. If it does equal 0, then the second derivative test fails and you have to use something else, probably the first derivative test. Okay, so let's do this and see how it goes. So we have f of x is 7x squared minus 21x plus 5. I'm going to use a different color. I'm tired of this color. F prime of x would be 14x minus 21, which is continuous everywhere. So we don't need to worry about discontinuities, but we do need to figure out where it is equal to 0. So 21 is 14x. So x is what, 3/2. And so what you would then do, I wrote that down as 2, but 14 doesn't go into 21 twice. Okay. If you take a second derivative, so we have done, this is step 1, this is step 2, this is step 3, f double prime here is 14. Step 4 is that f double prime anywhere is positive because it's 14, which tells us then, because it's up like a cup, this we have a local min. And that happens at 3/2 and then f of 3/2, which I need to go figure out. 7x squared minus 21x. F of x, oops. X squared minus 21x plus 5. And we want to know what 3/2 f of x is. Oh, what's wrong with that? 3/2, no. 3/2 would be here. Why did not do that? Do I need to write it as 1/2 or 1.5? Space problem. Space problem. No. Don't know what's going on there. Whoa. Okay. Well, anyway, you can see the minimum there at 1.5 negative 10.75. Okay. Let's keep going. So we have f prime of x would be 9x squared minus 18x here. That's continuous everywhere, but let's set it equal to 0. Factor out of 9x, we get x minus 2. So we have CVs at x equals 0 and positive 2. It says steps 1 and 2, find f prime, find the critical values. Step 3 would be to find f double prime, which would be 18x minus 18 in this case. And then check to see if f double prime is positive or negative at our critical value. So f double prime of 0 would be negative 18, which is less than 0. F double prime of 2 would be 18 times 2 minus 18, so it would just be 18, which is greater than 0. So down like a frown means you're looking at a local max, and up like a cup means you have a local min. So we have 0 something for the local max, and 2 something for the local min. To figure out those somethings, go back to the original function and plug in 0, so that would give us 8. Plug in 2, blah, blah, blah. F of 0 is 8. F of 2 would be 2 cubed is 8 times 3 is 24 minus 36. 24 minus 36 is negative 12 plus 8 is negative 4. Okay, so local max at 0, 8, a local min at 2, negative 4. Switch it up again. F prime of x, we're still trying to find local extrema using the second derivative. So find the first derivative, find the critical values, find the second derivative, and then check whether the second derivative is positive or negative at your critical values. So 4x cubed minus 36x, which is continuous everywhere. Set this equal to 0. And we have 4x cubed minus 36x. I'm going to take out a 4x. So I have x squared minus times 4 is 36. So we have x equals 0 from this guy and plus or minus 3 from that. And then we're going to find f double prime, which is 12x squared minus 36. And we're going to check our things. So we're going to do f double prime of negative 3, f double prime of 0, and f double prime of positive 3. So if you plug in 0, that would be negative 36, which that's not a 0. This would be negative 36, which is less than 0. If you plug in negative 3 here to f double prime, that would make that positive 3. 12 times, well, 9. 12 times 9 is much bigger than 36. So this would just be positive. I don't know how positive. Same thing when you plug in 3, it'll just be positive. So we have up like a cup, which gives us a local min. We have down like a frown, which gives us a local max. And another up like a cup, which gives us a local min. So we have local min, local max at 0, and then plug 0 back into the original function f. That would be 0. Min's at -3 something and 3 something. Plugging in 3 and -3 here, it doesn't matter. 3 to the 4th minus 18 times 9. This is -81. That's because f of -3 equals -81. F of 0 is 0, and f of 3 is -81. Okay. I don't want to do all of these. Actually, it's not that bad. Let's just do them. If you don't want to watch anymore, that's fine. Number 4, f prime of x would be equal to 2 minus 8 times x to the -2, which is undefined at x equals 0. And then we would set the whole thing equal to 0. So we have 8 over x squared equals 2. So 8 equals 2x squared. If you divide by 2, you get 4 equals x squared. So x is plus or minus 2. So we need to check 0, -2, and +2. We need to find f double prime first. So that would be what, 16 x to the -3. Okay, so f double prime of -2, f double prime of 0, and f double prime of +2. That's 16 over -8, which is negative. If we plug in 2, this would be 16 over 8, which is +2. This guy can't be a point of inflection. Sorry, I messed that up. It's undefined at x equals 0, so it's not a critical value, and it's not POI. It is not a critical value is the thing to take away from that. So we don't need to include it when we do this, because it can't be a min or a max because it's not defined for the function. Okay, so down like a frown would be a local max. Up like a cup would be a local min. Okay, so then actually plugging those in, -2 something and 2 something. This is a local max. This is a local min. And we plug those into the original. We have -4 minus 4, so -8, and 4 plus 4, so +8. Okay. Number 5, f prime of x is 4x cubed plus 6x squared, which is continuous everywhere, but let's see where it's equal to 0. Equal to x squared out. I have 2x plus 3. Okay, so x equals 0, and So x is -3/2. So we need to find the second derivative. That's 12x plus 12x squared plus 12x. And so we will want to check at f double prime of 0, which is 12 times 0 squared plus 12 times 0, which is 0. And that is a problem. Second derivative test doesn't work. So we want to use the first derivative test. So you're going to use an f prime number line. F prime number line with 0, with -3/2 and 0 on it. And do your test values. Let's do -2, -1, and 1. And so f prime of -2, f prime of -1, f prime of 1, f prime of -2. I'm plugging in here. That would be -8 times 4, which is -32 plus 24, which isn't, that's still negative. Then if I plug in -1, 4 plus 6, that's positive. I plug in 1, that's positive. Okay, so we have decreasing, increasing, increasing. So decreasing in, increasing out, and then still increasing. So you have a local min at -3/2, whatever f of -3/2 is, which I have is 5.6875. All right, number 6. Actually, let's rewrite this. This would be x plus 9 times x to the -1. So f prime of x is 1 minus 9x to the -2, which is undefined at x equals 0. So it's not a critical value. And then we also need to set it equal to 0. Or call this 9 over x squared equals 1. So we're looking at 9 equals x squared. So x is plus or minus 3. And then you're going to test those values or find the second derivative before you do that. So positive 18x to the -3 or 18 over x cubed. So f of -3 and f double prime of -3, f double prime of 3. That would be negative. Plugging in here would stay negative. Plugging in there would stay positive here. So down like a frown means you have a local max. Concavity is up like a cup means you have a local min. So we're looking at -3 something and 3 something local min, local max. -9 plus 9 is not a size of 18 divided by 3, but by -3 is -6. And 18 divided by 3 is 6. Okay. That is f of -3 equals -6. F of 3 equals 6. All right. Last one. We have for 4.1, f prime of x is 2. Actually, I am going to, maybe I'm not. exponent down front, decrease it by 1 times the derivative of what's inside. So we're looking at 4x times x squared plus 10, which is 4x cubed plus 40x. But going back here to find the critical values, it's defined everywhere, so you don't need to worry about that. But this is 0, or CVs are 0, is 0. All right, so then f double prime would be 12x squared plus 40. And if we plug in 0 to that, we get a positive. It's 40, which is positive. So it's concave up like a cup. So we have a local min at 0 something. This is f of 0, which is 10 squared, which is 100. Okay, so second derivative test, again, you find the first derivative, find the critical values to figure out what f double prime is, and then plug in and check to see if it is concave up or concave down, and therefore a minimum or a maximum. All right, thank you so much.